All right, guys. Welcome to Exponential Functions. This is the first video of the Exponential Functions unit. And an exponential function is where x is the exponent. That's the most important thing about an exponential function. X is your exponent. So you're going to see Miss Delk write that real quick. Most important thing, when you see x is the exponent, it's called an exponential function.
And it even kind of sounds like that. Exponent.
It really does, doesn't it?
X is the exponent.
All right, we're going to show you two types of exponential functions. One of them is going to represent exponential growth, and one of them is going to represent exponential decay. All right, this video, we're just going to deal with when you see the exponential function, we're going to identify growth or decay, the initial value, and then what is the rate of growth or decay. You're also going to see videos graphing exponential functions, and then you'll see a video on exponential function word problems.
And exponential is probably a word that you've heard lately on the news, because when we're talking about, COVID-19, and they're talking about how it's growing exponentially, this is exactly the type of function that they would use to represent that data.
Absolutely.
So it is, in fact, useful in real life.
It's true. Okay, let's start with exponential growth. This is the first one we're going to deal with right here. Notice that the general equation, or the parent equation of exponential growth, is y equals a times b to the x.
All exponential functions have this parent function.
Yes.
Depending upon what a and b are as their values will determine whether we're growing or decaying.
All right, a, right here, our first a. So whatever number is in A's spot.
The number out in front that's being multiplied. Remember, we even had a out in front of quadratics in vertex form because it was the number outside. It does deal with vertical translations as far as shifting the graph, not shifting, as far as compressing and stretching graphs.
Yes. All right, A is going to be known as our initial value. Okay, also, initial value could also be a starting point. And it will also represent your y-intercept.
As long as there aren't any other transformations.
That's right. In parent form, A will be your y-intercept as long as there are no other transformations to the parent equation. Let's make that clear. I'm glad you said that, Ms. Delp. Things could happen to this. Transformations could occur changing it.
It's where it initially would have been the y-intercept as long as there is no h or k value.
All right. Okay, if b is greater than 1, you see our little note right here, if b is greater than 1, we consider that exponential growth. So when they ask you about growth or decay, we're going to look at the b value and determine
B is always
growing.
the base that has the exponential exponent because b is our boss.
Yes, he tells us what to do, whether to grow or decay. We like to call him the boss. All right, then b is always
1 plus the rate.
That's right.
In order for it to have been greater than 1, we would have to have taken 1, which is the parent function, and added the rate to that.
Okay, so notice that in the parent equation, b would be a 1, like in the perfect parent equation. B would be a 1, but depending on what number is there, if it's greater than 1, it's growing, and we need to find the rate of growth. So anything, the rate would be, how do I say that, Ms. Delp? The number larger, or the percent larger than 1 turned to a rate. How do I say that? What could we say right there? There we go. Ms. Delk's actually writing it out for you so you can see it. 1 plus r, and then to the x.
B can be broken down.
B can be broken down into 1 plus the rate. Remember that in the perfect parent equation, it would be a 1. Okay? All right. So then R
is what we added to 1 to get this value of B. And we always talk about the rate as terms of a decimal. So it's either a growth rate
or a decay rate.
Or a decay rate. Now, a lot of times, you'll see here in a little bit when we're given word problems, they'll give us the rate as a percent. It's usually written as a percent. But in order to have substituted into this formula to get this B value, it would have to have been turned into a decimal, which we'll see in a little bit.
Yeah, we'll practice that in a minute.
Okay, so growth, A is the initial value. B can be broken down into either 1 plus the rate. So as long as B, the boss with the exponent, is greater than 1, it's growth.
That's right. Okay, now let's do the same thing for decay. Notice the function looks the exact same.
Yeah, A is still our initial value.
Yep. Still going to be our starting point, and it's still going to be your y-intercept if no other transformations have occurred.
True. Now, B can still be broken down. Remember, we keep talking about, so we could have y equals A.
Initial value, starting point, times
1 minus.
Because we're losing, we're decaying, so we're going down.
The rate.
And then to the x. Remember that raising it to the x is what makes it exponential.
Okay, and this is B broken down. So normally you won't see it written like this because it's simplified.
Right.
However, just know that if our B value right here is broken down and it's less than 1, it's because they had 1, the perfect one of the parent, and they subtracted the rate, which is why it's less than 1. It is then decay.
So you'll know just from looking at your B value if you're growing or decaying.
And in order for it to have been less than 1, we would have had 1 minus the rate.
That's right.
And R is, in fact, our decay rate.
Remember, when we say rate, we most of the time mean decimal, but they're going to give it to you as a percent. Okay.
So let's show you, for example. So here's a couple examples. They want us to identify the initial value, the growth or decay factor, and the growth or decay rate of the exponential function. I'll zoom this on up a little bit so we can actually see what I'm talking about. Remember, A is always the guy out in front. He's the starting point. He's outside being multiplied. So on number 1, A would be 3. So our initial value is 3 because A is initial. It's starting. That's what initial means. Okay. B has the power because he's the boss.
Yep, tells us what to do.
And we got to determine whether we're growing or decaying. Remember, growth is greater than 1, decay is less than 1. 1.8 is greater than 1, so this is growth.
Growing.
And then they want us to determine, well, what was the growth or decay rate? So we had to figure out what did they add to 1 to get it to become a 1.8. So if we think about this logically, 1 plus 0.8 would be
1.8.
Our rate. So our rate is 0.8. Now,
they always like that as a percent. Write that out for me, Estelle. 1 plus 0.8.
So 1 plus 0.8 would have given us 1.8. Remember we said when we broke it down earlier that it's 1 plus the rate. So here's our rate.
That's all right.
But we would have originally had it as a percent. So to go back to a percent, we have to move the decimal 2 times to the right.
Yeah.
So once, twice, fill in. That's an 80% growth rate.
Okay. Go. Look how easy that is.
I'll show you again.
Easy enough.
Here, guy out in front. Notice that this is an exponential because x is the exponent. A is our initial value out in front, starting us off.
So 2.1, that's easy.
Okay, B is the boss because he has the power.
That's right.
Notice
so
that.
B is 1.04.
So greater than 1, less than 1.
Greater than 1, definitely.
So it's a growth. How much is it more than 1 will determine the rate. So we are at 1.04. What did they add to 1 to get that? Well, that'd be 0.04.
Remember, if we're going from a decimal to a percent, Estelle's going to move that decimal twice.
When I do that, it's 0.4. We don't need a 0 in front, so that's a 4% growth rate.
Look how easy that is. Okay, and that's why a lot of y'all like this, because this part of this is super easy.
Yep, I'm going to do a couple more for you. Let's go do number 3. Same type of question. Okay.
So
notice it's an exponential because x is the exponent. A is the guy out in front being multiplied. He's our initial value. B is our boss. He determines whether we're growing or decaying. And the reason he's the boss is because he has all the power. Boss has the power.
That's right.
Greater than 1, less than 1?
That one's less than 1. 0.8 is less than 1.
So we have decayed.
So this one is definitely decaying, going down.
So we have 0.8. We got to
That's
figure
right.
out 1 minus what would have given us 0.8 or 80 cents. I like that.
That's right. That's what I have money. So 20 cents. We would have been 20 cents short for our 0.8 because you are great at money.
Move the decimal.
Twice to the left.
To the right.
Or to the right. I'm upside down, guys.
So that would be,
Yeah.
that would be a decay rate
of 20%.
of 20%.
Look how easy that is.
Super easy. Let's do number 5.
Definitely. Ooh, look at number 5.
Number 5, y'all like to get tricked up on these. Don't remember, it's always written as y equals A times B to the X. B's the boss. He has the power. A lot of times when we ask you what's the initial value here, you would tell me 0.3, but 0.3 is not the number out in front.
Nope.
0.3 has the power, so he's the boss.
They just didn't put him in parentheses. They're kind of confusing you.
So technically we could have written it like this.
That's right.
I'm gonna fake it till I make it.
That's right.
And now I gotta figure out what numbers out in front being multiplied.
The only thing that wouldn't change it would be a 1.
Identity, property, and multiplication. So our initial value is 1.
Remember, that number's so perfect in algebra, we don't show it half the time.
B is our boss.
He's definitely less than 1.
So he's a decay.
Think about that as money, guys. He's only 30 cents.
We have 30 cents. We were supposed to have $1. We subtracted something.
70 cents.
Move the decimal 2 times to the right to go back to its percent.
There we go.
70%.
Look how easy. I think we should do number 6,
Let's do
Miss
a word
Dell.
problem. See how it's actually applied in.
I think we should do this one. Yeah. Look
Okay.
at that one because they'll sometimes get this one confused.
So y equals 3 times 2 to the x. A is always out in front, being
Definitely.
multiplied. So
A would be 3. All right, our boss.
he has the power. So B is 2. Well, that's definitely greater than 1.
Definitely.
So it's a growth. We got to figure out how much do we grow by. So we have 2. We started with a perfect 1. What did we add to it?
They added a 1.
Well, yep. So then you take the decimal. Can't see it, so I want to put it there. Move it 2 times to the right. Fill it in. So we had a growth rate of 100%.
Look at that. He's growing 100% more than he should be.
Yep.
Okay. All right. Number 7. Here we go. It says the Johnson Company calculates the value of its stock each year by using the function y equals 120 times 0.98 raised to the x. They would like us to identify growth or decay, initial value, and growth or decay rate.
Notice that it's an exponential because x is the exponent. A is the initial value out in front being multiplied. So that one's always
20.
easy.
Yeah, I can't mess that one up.
B's our boss because he has the power. So this has the power. So there's our boss.
He's definitely less than 1, Miss Delp.
So decay. Then we got to figure out, well, how much did he decay by? We have 0.98. We started with $1. What did we subtract from $1 to get 98 cents?
2 cents.
Subtracted 2 cents. Move the decimal 2 times to the right to get back to its percent. So that would be 2%. So we have a decay rate of 2%.
See how easy that is, guys?
Super easy.
All right, let's do one more. It says Selena's starting salary for her new marketing management job is $32,000. She calculates her projected salary for the next 5 years by using the function y equals 32,000 times 1.12 to the x.
Okay, so we got to use this to answer these questions. Notice that it's an exponential because x is the exponent. A is our initial value. It's always out in front being multiplied. So her initial value or starting is even here in the word problem would be $32,000.
When she got hired, that's her starting salary.
That's a nice starting salary. B is our boss. He has the power, so I'm looking for the guy with the exponent. That'd be 1.12.
Definitely growing. Hopefully, if you're working longer at a job, you're getting a raise, your income is increasing.
We got to figure out how much did it increase by. So we're at 1.12. We had $1. What did we add to that dollar to get
12
to?
cents.
Take the decimal.
Move it twice to the left.
to the right.
Ah, shoot, I'm upside down
She's
again.
upside down.
I am upside down.
So 12%.
Not even thinking about it.
Now, if we were going backwards and I had given you the percent and I needed to plug it into the formula, I would have to move the decimal 2 times to the left.
Yes.
So it just depends on which way we're going. If you're going from a decimal to a percent, it's 2 times to the right. If you're going from a percent to a decimal, 2 times to the left.
All right, that is just the basics.
Yes,
Growth or decay exponential functions. Just basically, can you identify if it's growing or decaying, the initial value, and the rate of growth or decay? Okay?
Okay, bye guys.
Bye.